All right, let's jump right into this. Today, we're looking at a pretty fascinating company called AEGIS Critical Energy Defence. Now, a quick glance might make you think they just make batteries, but honestly, that completely misses the bigger picture. AEGIS is actually positioning itself as a critical, long-term energy technology platform. We're talking about the absolute essential, high-tech infrastructure that keeps the world running when failure simply isn't an option.
Okay, let's dive into this. We're all living through an absolute explosion in artificial intelligence right now, right? And this AI adoption is driving the construction of massive data centers all across North America. But here's the major roadblock. These colossal facilities require an astronomical amount of power. Connecting them directly to our traditional public grid is rapidly becoming impossible. The grid just can't handle it. So, how do we actually power this AI boom without crashing the very systems we all rely on? Well, that's the exact problem AEGIS is working to solve. So here is our roadmap for this explainer. We'll start with the critical power problem, look at the missing intelligent link, and compare SHOTs versus SIPs. Then we'll explore sovereign and secure tech, resilient power today, and finally wrap up with their energy technology roadmap.
All right, Section 1, the critical power problem, when the grid isn't enough. Modern mission-critical operations are facing what's essentially a perfect storm of challenges. First off, they often operate in remote, incredibly harsh environments. Think places like the Arctic, where temperatures can plummet to minus 50 degrees Celsius. Second, they involve incredibly dynamic, fast-changing power loads. AI data centers and military radar systems don't just draw power smoothly. Their power demands dance around erratically. And finally, as everything becomes hyper-connected, they face massive cyber and supply chain exposure. Now, you might be wondering, why not just use solar and wind? Well, renewable energy is often just too stochastic, basically too unpredictable for these life-or-death missions. And our traditional grids alone simply aren't built to handle these erratic, specialized demands.
Which brings us to Section 2, the missing intelligent link, bridging generation and load. This is exactly where AEGIS fits into the equation. They aren't actually building the power generators themselves. Instead, they provide the highly intelligent control layer that bridges that heavy power generation and those rapidly fluctuating loads we were just talking about. To provide steady base power for these massive off-grid loads, the industry is increasingly looking toward small modular reactors, or SMRs. And from an engineering perspective, modern SMRs are completely different from legacy nuclear plants. They're passively safe, meaning they're engineered so a runaway reaction is prevented by design, even if the controls fail. They're modular, they can literally be transported on trailers, and they can be built in under a year. They provide an incredibly reliable base layer of power. But here's the catch with nuclear, and honestly with diesel or gas generators too. They want to run at a steady, consistent output. They cannot rapidly adjust to sudden, massive spikes in power demand. So the crucial point here is perfectly summarized by AEGIS CEO Ramtin Rasulinejad. You size your power source for the average load, and you let a highly advanced energy storage system absorb all those rapid spikes and drops. That intelligent energy storage system is AEGIS's specialty. They are the missing link.
Let's move on to Section 3, SHOTs versus SIPs, the high C advantage. Now, what's really interesting about this slide is how it frames the actual job of the battery. Think about it. Legacy batteries are built for the SIP. They're designed to discharge power slowly and steadily over many hours, which is perfect for smoothing out solar power when the sun goes down. But AI and heavy industrial ports, they don't sip power, they gulp it in erratic, rapid bursts. AEGIS is developing high-C technology, which acts like the SHOT. It's engineered to deliver instant, millisecond-scale bursts of massive power, instantly refill and repeat the process. Because this high-C tech is designed for those short, intense power bursts rather than long, slow drains, the physical storage footprint shrinks dramatically. We're talking about a 400 to 600% improvement in performance and footprint. Think of it like jumping from a propeller plane to a jet engine. You need drastically less installed battery energy, less cooling, fewer battery materials, and far less maintenance to get the exact same job done. It's a total game changer. Next up is Section 4, Sovereign and Secure Tech, hardening the infrastructure.
Look, having a powerful battery isn't enough if an adversary can just hack into it, right? So AEGIS operates a dual-track strategy to harden infrastructure both digitally and geopolitically. Let's tackle the digital side first. AEGIS integrates something called QRNG. That's quantum random number generation. Through a partnership with Quantum Emotion, they're building true hardware-based quantum entropy into their systems. Without getting bogged down in extreme tech jargon, this essentially means the control interfaces that manage the power are protected by secure, unhackable keys. It completely prevents catastrophic cyber exposure that could otherwise bring down a military base or a major AI hub.
And then there's their brilliant geopolitical strategy. Instead of relying on a single, potentially vulnerable global supply chain, AEGIS uses a hybrid approach. They source the physical premium battery modules from trusted allied nations like Germany and Taiwan. However, the vital brain of the system, the control, intelligence, and energy management system, remains proprietary Canadian intellectual property. Furthermore, they've established a crucial partnership with Malahat Energy Systems, an indigenous-led business which opens up specific secure procurement pathways all across North America. It really is a masterclass in energy sovereignty.
Section 5. Deploying Resilient Power Today. Commercial Readiness.
So it's important to know AEGIS isn't just a research lab. They have active products out there today. The Tough Boy system is a mobile, incredibly rugged unit that's Arctic ready down to minus 50 degrees Celsius. Alongside that is the PWR Flex 261Q, which is a factory-assembled, plug-and-play battery energy storage system for commercial use. Crucially, these systems boast a technology readiness level of 9 and UL 9540 certification, meaning they've hit the absolute highest global standards for commercial deployment and safety. They are actively generating revenue and providing resilient power to defense and industrial sectors right this very minute.
Finally, Section 6, the Energy Technology Roadmap, 3+1.
This roadmap builds rapidly over a multi-year horizon, and it's backed by a multi-million-dollar research and development partnership with McMaster University. Today, as we mentioned, they're deploying their legacy-compatible units, Tough Boy and PWRFX. Within year 1, they're targeting the rollout of their advanced, high-C technology specifically designed for those erratic AI data centers. By year 2, they plan to expand that high-C tech into massive port and crane electrification projects. By years 3 and 4, the big goal is to fully integrate their systems as the intelligent bridge for SMR and MMR nuclear microgrids. And their +1 visionary goal? Integrating all of this into floating power plants to deploy resilient energy anywhere on the globe. Which leaves us with this final, vital question to ponder. As AI, defense, and global critical infrastructure demands completely outgrow our traditional electrical grids, who is actually going to control the intelligent bridge to our energy future? Will we rely on vulnerable, imported tech, or will we champion sovereign, quantum-secure platforms like the one AEGIS is building? It's absolutely a fascinating space to watch, and I hope this explainer helped you grasp the incredible engineering driving it all. Keep learning, and we'll see you next time.